Dear viewers, welcome to our channel at Steve Getao 3660. In our today's lesson, we shall do a continuation of the series of lessons in Form 3 Mathematics. Today's lesson will focus on solving logarithmic equations. This is one of the topics that we selected as having posed challenges to learners, and we would like to give some revision questions as the learners go over the topic and they will have a better understanding of the topic. Viewers, kindly subscribe on the video, share and make comments so that we may grow the channel. Once more, welcome, and straight away, let's go to the lesson. We have a question here. Number 1, solve the equation below for the value of x. The question is 2 logarithm of x minus logarithm into brackets x minus 2 is equal to 2 log of 3. In this particular question, we have the logarithms given without any particular base. We shall assume that we are going to use base 10, though it's not necessary to work on it. The most important thing to recall here are the basic rules of logarithms, which we shall apply. Number 1, when the logarithm has a multiplier, that multiplier can be put as a square to the number. That is to say, this part becomes logarithm of x squared minus, or subtract logarithm of x minus 2, and once more, this becomes the power or the index to 3, that gives you logarithm of 3 squared. We can work it out 3 squared as 9 in the second step. However, the second rule of logarithm says that when we are subtracting logarithms, the numbers themselves are being divided. Which are our numbers? Our numbers are x squared and x minus 2. So if we factor out the logarithm, we are going to have the log of, into brackets, the numerator will be x squared, while the denominator will be x minus 2. We close the bracket, and that should be equal to the log of 9. So you find that this logarithm of this particular number is equal to the logarithm of 9. So on both sides, we have logarithms. We can now move to a third step, whereby we say you drop the logarithms and then you are left with the numbers. How does it go? We get x squared all over x minus 2 is equal to 9. At this point, we have dropped logarithms on both sides. What does that one give us? We are now left with an equation here, whereby on the left-hand side, we can multiply with x minus 2, and we repeat that process by multiplying by x minus 2 on the right-hand side, such that this part divides out, and we are left with the expression or the equation x squared is equal to 9x minus 18. 9x minus 18. We form a proper quadratic equation whereby we get x squared, we bring this onto this side, minus 9x, we add 18 on both sides, and that gives you a 0. This forms a very good quadratic equation. So we have moved from a logarithmic equation, now we have a quadratic equation which we shall solve by the simplest, or the method that you as a learner feels most comfortable in. We attempt the simplest approach, and that is factorization. We factorize by looking for two numbers whose product is the 1 times 18. The product is 18. We look for two numbers whose product is 18 and whose sum is negative 9. Whose sum is negative 9. So viewers, we need to look for this kind of numbers. Which two numbers shall we multiply and get 18, positive 18, and when we add them, we get a negative 9. So we look through this and we get the suitable numbers are negative 3 and negative 6. When we add the two, we get negative 9. When we multiply the two, we get positive 18. These two numbers, this set of two numbers, we are going to substitute them at this point in the middle term. And what does that give us? It gives us x squared minus, we may start with 3x, minus 6x plus 18, now plus 18 gives us is equal to 0. We take the first two and we factorize what is common and we factorize in the second set. In x squared and in 3x we get an x into x minus 3. And in negative 6x and 18 we have 6. We may factor it out as negative 6 so that we are left with x. Viewers, we take a lot of caution here. Negative 6 to get us positive 18 with negative 6 out here, and we want a positive 18, the inside must have negative 3. So that negative 6 multiplied by negative 3 gets us 18, and that is equal to 0. We put like terms together, whereby we pick this multiplier and this one as x minus 6 and x minus 3 are one of the factors, and that is equal to 0. At this point, now we are saying there are two numbers which when you multiply, gives us 0. Either x is equal to 6 or x is equal to 3. With that, we are able to find the values of x. When we substitute x into each of these, we are going to get that. Take for example 6. When we have 6 put here, and at this point, we are left with a positive value in each case. The same case with the 3. So there is a point whereby you need to be cautious. Whenever you get x is negative, one of the values possibly is negative, you need to check if it is working truly in your work. At this point, we need to look at the marking points. When the student is able to drop the logarithms at this level, we give a mark. First, M1, method mark. When the student is able to do the factorization and gets the factors, preferably either at this level or at this point, maybe we can give it at this point, we get you an M1. And then having the correct final answers accurately done, A1, and this is for both of them. That is, x is equal to 6 and x is equal to 3. And at this point, that question earns the student 3 marks. Let's move on to question number 2. In question number 2, we find that we are required to find the value of x in logarithm of 7x minus 3 plus 2 log of 5 is equal to 2 plus log x plus 3. In this case, looking at the question, we have some parts like this one, whereby a number is given and it is part of the logarithm part. So we need to convert all to be in logarithm form, such that we ask ourselves, if we take base 10, which is the conventional base, how will 2 be? That leads us to a rule in logarithm which says the logarithm of a to base a is 1. And therefore, if we can use base 10, then logarithm to base 10 of 10 is the one which is equal to 1. However, viewers, in our question, we have a 2. So if I multiply this with the 2, I will come and multiply that with a 2. We do not need to have the brackets. Now, with our earlier argument, this multiplier should move here so that we have log to base 10 of 10 squared. Logarithm to base 10 of 10 squared, which is equal to logarithm of 10, logarithm of 100 to base 10. And that is how we work out the 2. So if I may delete this and now move to the question, we shall have that log 7x minus 3 plus log of 5 to power 2. We shift this up here, will be equal to log of 100 plus log x plus 3. We have agreed to use base 10. So the 2 becomes log to base 10 over 100. At this point, we look at the addition rule in logarithms, whereby when we are adding logarithms, the numbers are being multiplied. And that leads us to the situation of log into, we take the numbers 7x minus 3, 7x minus 3 all over, we are multiplying, so I will have this multiplied by 25, and then I can close the bracket. So the numbers are multiplying because we are adding their logarithms, and that comes to be the logarithm of, once more, we take 100 multiplied by x plus 3, and we can close that. So in this case, the expression or the equation is becoming simplified in the sense that at this point we can drop the logarithms so that we have 25 into 7x minus 3 is equal to 100 into x plus 3. Now we can make it more simple by dividing by 25 on both sides, so that we get divided by 25, this comes to be 1, divided by 25, this gives you 4. So that gives us 7x minus 3 is equal to, we work out and we have 4x plus 12. We are simplifying the equation at every level. At this point, we can put like terms together. We subtract 4x on both sides and we add 3 on both sides. And that gives us 7x minus 4x is equal to 12 plus 3. What does that give us? 7x minus 4 is a 3x, and 12 plus 3 gives you 15. We simplify by dividing by 3, since we want the value of 1x. Divide by 3, and we get that x is equal to 5. That way, we are able to use the rules of logarithms in solving such kind of a question. Viewers, I would like to summarize that and say, at this point, we took base 10 because it is the conventional base in mathematics, and logarithm to base 10 over 100 is 2. Then we looked at the addition rule of logarithm that says when you are adding logs, you multiply the numbers. At that point, we are able to multiply, and the rest of it is arithmetic simplification. How do we award the marks at this point? You find that when the learner is able to have this change, it is a very, very important step, and it is a key step we give M1. When the learner is able to drop the logarithms and multiply the numbers, that is a very key step, M1. And finally, the accurate answer, x is equal to 5, answer mark, and that gives the learners 3 out of 3 marks. Viewers, let us look at question number 3. In question number 3, we are having solve for x, given that log into brackets 15 minus 5x, close the bracket, minus 1 is equal to that, 3x minus 2. So how do we go about solving this kind of a question? Once more, we have the freedom to assume base 10. Here, the 1, as we had said earlier, can come to be log to base 10 of 10, which is equal to 1. So when log to base 10 of 10 is equal to 1, we can easily substitute the 1 for this one. That gives us log into 15 minus 5x minus log to base 10 of 10 is equal to logarithm of 3x minus 2. So we have managed to shift 1 to be a log of 10 to base 10. And we assume all the other numbers are to base 10, the conventional base. With that, we come to the subtraction rule of logarithms that says when logarithms are subtracted, or when we are subtracting two logarithms, their numbers are being divided. And that gives us the expression, the logarithm, as the numerator becomes 15 minus 5x divided by 10. So this is what is represented up here. When we are dividing logarithms, when you are dividing numbers, their logarithms are being subtracted. And that is equal to the logarithm of 3x minus 2. Since we have a logarithm on this side and also on the other side, we can drop that function of logarithm so that we are left with the numbers. Which are these numbers? The numbers are 15 minus 5x divided by 10 is equal to 3x minus 2. So at this point, we simplify the equation so that we get the value of x. So we may multiply this left side by 10. We multiply the right side by 10. And what does that give us? It gives us that 15 minus 5x is equal to 14. 10 times 3x is 30x. Negative 2 by 10 is negative 20. At this point, we put like terms together. That means we shall add 5x on both sides. We shall add 20 on both sides. That comes to be 15 plus 20 is equal to 30x plus 5x. And that gives us that 35 is equal to 35x. Indeed, we are seeing that 5x is equal to 35. We divide both sides by 35 and we are able to get that the value of x is equal to 1. The value of x is equal to 1. Now, viewers, we have had 3 examples with various tricks that we are using to solve them. And before we move on to question number 4, let us let's give the marking point. When the student is able to change negative 1 to be log, that is a 1 to be log 10, that is a very crucial point, M1. The student is able to take off. Then the second step is where the student is able to see that we are subtracting logs, so we divide the numbers. that is a very crucial point, M1. And with the simplification, the student earns an A1 for correct and accurate answer, and that way the student is able to get the 3 marks out of 3 in such kind of question. Now, viewers, I would like us to make this lesson quite interactive. So, we are going to have question number 4 and number 5. We will provide the questions. You will work them out such that first pause on the video so that as you work the 2 questions out, you'll be able to tell how well you are able to master the operations on solving the logarithmic equations. So with the question number 4 and 5, I will write them down. You'll pause on the video and then work it out. Then later on, play on the video, and then you'll be able to get how we are arriving at the answers. Welcome back. We have question number 4 and question number 5, which, viewers, I would like you to note down in your notebook, work it out, and as we resume, we shall provide with the solution. This is going to make our online lesson very interactive. It will also give you an opportunity to test on the skills that you have so far acquired. The question number 4 reads, solve for x in the equation 2 log of 15 minus log x is equal to log 5 plus logarithm of into brackets x minus 4. Question number 5 says, solve for x in the equation a half logarithm to base 2. Here we have a base 2 for all items in the question. A half log to base 2 of 9 plus logarithm to base 2 of 5x minus 4 is equal to 7. So viewers, work it out, pause on the video, give yourself 2-3 minutes to work out the 2 questions, and then play on to find out what was the expected solution. Welcome back. I want to believe that you have had an opportunity to work out this question, and so together let us see what is the expected working for this question. Whenever we have a multiplier to a particular logarithm of a particular number, then the multiplier becomes the power or the index. So this gives us log of 15 to power 2 minus log of x being equal to log of 5 plus log of x minus 4. In step number 2, we see that whenever we are subtracting 2 logarithms, their numbers, the logarithm of those numbers, we take on the numbers and divide them out. So it's going to be logarithm of 15 squared is 225 divided by x, and that is equal to, these 2 numbers are being, these 2 logarithms, I beg your pardon, are being added. Whenever we add logarithms, the numbers are being multiplied. So this becomes the logarithm of, I have a 5 into x minus 4, and I close the bracket. So at this point, we may drop the logarithms and we shall have 225 all over x is equal to, we drop the logs and that gives us 5x minus 20. We remove this denominator by multiplying throughout by x, and we shall have 225 is equal to 5x squared minus 20x. That is, on each side of the left-hand side, we multiply by x, and also on this other side, the right-hand side, we multiply by x. So this x cancels out with that one. We get 1, 1, whilst this, we put it inside the bracket. So we get 225, and this is 5x squared and 20x. We form a proper quadratic equation starting with the highest power of x. That is 5x squared minus 20x. We push this onto this other side and subtract 225. That gives us now 0, because we remove 225 from this side, and that gives us a 0. We may simplify the entire quadratic equation by dividing throughout by 5. And what did we get? We get x squared minus 4x minus 225 divided by 5 gives us 45 is equal to 0. At this point, viewers, we look for a suitable method of solving this quadratic equation, and that is by factorization. So we factorize and we look for two numbers whose product is negative 45 and whose sum is negative 4. Which are these two numbers? Which when you add, you get negative 4. When you multiply, you get negative 45. So work it out, and I want to believe that you got negative 9 and positive 5. When you add the two, you get negative 5. When you multiply, you get that. So we bring in these two and substitute them at the middle term, and that gives us x squared minus, we may start with 9x, we add 5x, subtract 45 is equal to 0. Factorize what is common in x squared and in 9x, we get is an x, and that gives you x minus 9. Then factorize what is common in 5x and in 45, that is a 5, and that gives you x minus 9, and that is equal to 0. Put the factors together, and that is x plus 5, and one of them, the x minus 9, you take x minus 9 is equal to 0. When two numbers are multiplying and the result is a 0, either one of them is equal to 0. So either x plus 5 is equal to 0, that means x is equal to negative 5, or you may find that x minus 9 is equal to 0, and that means x is equal to 9. Now, it is important that we evaluate the correctness of these two answers. Take, for example, if I take x minus 5 and I substitute the x here, we shall have a situation of minus 5 minus 4. Minus 5 is the x, minus 4, with a result there of negative 9. Now, viewers, it is important to realize that there are no negative logarithms. There are no logarithms of negative numbers, such that the x minus 5 must be disqualified. We must disqualify this answer so that we are left with x is equal to 9 as the only answer. So we give x is equal to 9 and we disqualify x is equal to negative 5, since we do not have logarithm of a negative number. If we take on 9 here, you'll find 9 minus 4 is a positive 5. So that is workable here. Look at the marking points. The marking points for this will start at the point where the student drops the logarithms, and this is the point. The moment you're able to drop the logarithms correctly, you get M1. The moment the student is able to factorize and get the factors of the quadratic equation correctly M1, and when the student is put to disqualify x is equal to -5 and left with x is equal to 9, this gives you A1, and that student scores 3 out of 3 in that question. Let us move on to the last question here. In this question, we have a difference in the workings since our base is 2, but that should not pose any problem. We are required to find the value of x, which features here, and given that. So this question requires a combination of the rules of logarithm, whereby in the first case, this multiplier should come in as the index or the power to 9. And so we shall have log to base 2 of 9 raised to the power over half plus log to base 2 of 5x minus 4 is equal to, this is positive 7. We need to show it as a logarithm. So we are going to manipulate such that we have the rule that says logarithm to base a of a is equal to 1. Now, since our base is 2, then we shall have logarithm to base 2 of 2 is equal to 1. If all this is a 1, then if we multiply this part by 7 and this one by 7, then we have 7 log to base 2 of 2 being equal to 7. Our 7 can now be shown in this form. So what we are saying, if I may show this one, then this becomes logarithm. Allow me to put a 7 here, and then we shall change to this. 9, the square root of 9, that is log to base 2 of 3. 9 power half is the square root of 9 plus log to base 2 of 5x minus 4 being equal to 7 logarithm to base 2 of 2. We have agreed that log to base 2 of 2 is a 1. 1 times 7 is the original 7. So at this point, we are going to manipulate this 7 so that it becomes a power of 2 at this point. And as we do so, we could be manipulating the rule that says when logarithms are being added, we multiply the numbers. So this gives us on this side logarithm of 3 into 5x minus 4. You multiply the 2 to get us the logarithm of 2 raised to the power of 7 to base 2. The 7 here becomes the power here. If once we are able to see that we drop the 2 logarithms, we shall be able to get 3 times 5 is 15x minus 3 times 4 is negative 12 being equal to, we can drop the logarithms and then we get 2 to the power 7 is 128. It's 128. So at that point, we may put like terms together. This negative 12, we add 12 here and 12 on this other side to get us 15x is equal to 128 plus 12. That gives you 140. At that point, then we divide both sides by 15, and if we divide both sides by 15, this other side, we get x is equal to 9 and a third. 9, we get 9 and a third as the value of x. So, viewers, as we conclude this question, I'd like you to recall this section as being very important. That logarithm to base 2 of 2 is 1. But we want a 7. So we multiply both sides by 7. So our expression becomes 7 log to base 2 of 2 is equal to 1 times 7. So this 1 times 7 is 7. So we take this at this level, together with all the other rules of logarithm. Viewers, we come to the end of this session, but I would like us to mark and see where the method mark fall in. In this case, when the student is able to express 7 as a base 2, we have the first method mark, M1. When the student is able to drop the logarithms and is able to work without the logarithms, we get M1 and accurately A1 when this final solution is obtained. And that way, we are able to get 3 out of 3 for that kind of a short answer question. So viewers, it is my belief that you have had a very good interaction and you are able to understand the various rules of logarithms and how they are applied in solving logarithmic equations. Feel free to post comments or questions that may be difficult in the comment section and I will be able to reply. Also, do share this video with your friends and others so that we may grow the channel and we may be able to interact more. I would like to thank all for being with me at this in this channel at Steve Gitao 3660. Coming up after this, in Form 3 Mathematics, we shall be looking at commercial arithmetic 1, commercial arithmetic 2, whereby we shall be understanding more what is the relationship between compound interest and hire purchase. That's a very challenging area to most of the students. Whenever they are asked to find the rate of compound interest when an item was bought at hire purchase. I look forward to meeting you in the lesson on that one. I wish you all the best and let us keep on subscribing so that we may grow our channel. Thank you.